Alrighty, so last time we talked about how to convert between exponential form and logarithmic form. Okay, exponential versus logarithmic form. So we looked at, up on the board here really quickly, we looked at if I have 5 squared equals 25, there's actually another way that I could write that using a logarithm. That would look like log base 5 of 25 equals 2. And for 5 squared equals 25, where I know all the pieces, maybe that log is sort of a little silly to write, but it is helpful, we said, for problems where I've got something like 6 to some power, 6 to the x equals 30. Because I don't know what power of x, or what power of 6 would give me 30. So if I've got 6 to the x equals 30, this is a problem because I know it's not 6 to the first power, because that's just 6. I know it's not 6 to the second power, because that would be 36. So it's something between 1 and 2, but I don't know what exactly. So that's where a log may come in. I can rewrite this as a log of base 6 of 30. And then we'll talk about today how to use our calculators to evaluate log base 6 of 30, or things like log base 6 of 30, where that exponent isn't going to be a nice number. So again, last time we just talked about how to swap between these forms, take an exponential, write it as a log, take a log, write it as an exponential. Today, we're going to talk about how to actually evaluate logs. This is really similar to what we did at the very end of class last time, where we were writing in those alternate forms, but then also giving that missing value. So for something like 20, we had log base 2 of 2 equals a. We rewrote it in its exponential form, and then we said, what is a equal to? So what we'll be doing today is focusing on that evaluating piece for a log. What is this log equal to? So for our first couple of examples on page 12, as we are working through our problems today, I'm going to rewrite these in our exponential form, especially as we're sort of new to logs. For a lot of us, looking at that exponential form makes a little more sense because it's more familiar. So that's what I'm going to do as we work through for today. So for our first example, this would be 4 to what power equals 4. What does my exponent have to be here? 4 to what power? Give me 4. 4 to the first. So log base 4 of 4 equals 1. For my next example, 4 to what power gives me 64? 4 to what power would give me 64? Four to the third power, 4 cubed. So log base 4 of 64 equals 3. And then 6 to what power gives me 36? 6 to the second power, 6 squared. So log base 6 of 36 equals 2. That's what we're working on for today. As we're working through evaluating our logs, I want you to keep in mind that we have also worked not just with integer positive exponents, but also with negative exponents, also with rational exponents. So those may come into play as we're working on evaluating our logs. Okay. For my next row of problems, I've got to start 2 to what power gives me 1/8. I want you to notice here, I'm starting with a whole number and I'm ending with a fraction. So when I'm moving between a whole number and a fraction, what I know must be true is that I took a reciprocal, right? I flipped this. So what kind of exponent would tell me to take a reciprocal? What kind of exponent tells me to flip? A negative exponent tells me to flip. So it has to be negative something here. The negative tells me to flip. And then 2 to what power would get me to 8? 2 to the third power, right? 2 cubed gets me 8. So log base 2 of 1/8 would be -3. For my next example, 5 to what power gives me 1 over 25? -2, very good. The negative, because I had to take the reciprocal, and then 5 squared gives me 25. The hardest part about this is remembering that we're talking about exponents. We're talking about powers. So it is really tempting to say like 6 times 6, and then you tell me this log is equal to 6. But remember, it's not 6 multiplied by something. It's 6 to what power? Same thing here. It's not 2 times what gives me 8. It's 2 to what power? For our last example in this row, 8 to what power gives me 1 over 64? -2 again. The negative so that we take the reciprocal, and then 8 squared gives me 64. Very good. For our next line of problems, this would be 9 to what power gives me the 5th root of 9? Now, the tricky thing about this problem is that I want an exponent, and what we have here is a radical. What we have here is a root. But I can write roots as exponents, right? This would be 9 to the 1/5 power. What's the only thing that I could put in this box so that this side is equal to this side? 1/5, right? The exponents have to match. The next two problems are a similar idea, but a little bit trickier because here, the base for my log was already in my argument there. I already had a 9 here. But for the next couple, we don't have the base appearing in our argument. I don't have 6 to some power here, or just the root of 6. Same here, I don't have just the root, some kind of root of 2. So what we have to do is something that we did last week, which is to rewrite this so that they have the same base. So this would be 6 to what power equals, and then this would be 36 to the 1/3 power. But I don't know the cube root of 36. I can't simplify this so that it's easy to tell me what exponent to use for the 6. So instead, what I'm going to do is change 36 so that it's got the same base. Because I can write 36 with a base of 6, right? 36 is 6 squared. So this is 6 squared, right? This is my 36 part. And then to the 1/3 power. These are the same. All three of these are the same thing. 6 squared is 36. 36 to the 1/3 power is the cube root of 36. Those are all the same thing. But when I've rewritten to have the same base, now I can figure out what that exponent should be. Since I've got power to a power here, I would multiply. This would be 6 to the 2/3 power. So just like over here, where the exponents had to match, the exponents have to match. So this would be 2/3. This is a trickier problem. This is a tougher problem because I have to rewrite and apply those exponent rules. We're going to look at the same type of thing for our next example. This would be 2 to what power gives me this guy. The 4th root of 8 is not a nice number, so I can't simplify that. I can write it as 8 to the 1/4 power, though. That way I'm working with exponents. And then 8, I can rewrite to have the same base. I can rewrite 8 as 2 cubed, still to that 1/4 power. So now I can compare these a little bit easier. This would be power to a power I multiply, 3/4, 2 to the 3/4. So what does that exponent have to be so that these are equal? What's the only thing I can put at that box and this side be equal to this side? If this side is 2 to the 3/4, what does this side have to be? The same thing, right? 2 to the 3/4. These, I think, are our toughest problems for today. Let's take a look at our next couple of problems. 4 to what power would give me 2? Before I talk about this problem, I want to talk about a little bit different version of this problem. Let's say I have log base 49 of 7. So 49 to what power would give me 7? I want you to keep in mind, we are not dividing. I don't want you to tell me 49 divided by something to give me 7, although that's probably the easiest question to answer. What would I do to 49 to get 7? You cannot tell me divide. What else can you tell me? Not quite. We want to do the square root, right? Which would be 1/2 as our exponent, the square root of 49, okay? The square root of 49 would give me 7. That's the same idea here, but I wanted to talk about it with something different because 1/2 of 4 is still 2. But I don't want to take 1/2 of 4. I want to do the square root of 4 to get 2. I want you to notice for both of these, we are going from a big number to a smaller number. Both integers, no fractions here, but from a big number to a smaller number means we are taking some kind of root. Okay. We can represent a root with an exponent. A square root would be a 1/2 power. Now, let's modify that a little bit for this guy, because this wasn't quite the same problem, right? We have 49 to what power would give me 1/7? Well, what do I need to be true about my exponent so that it changes to 1/? I need it to be negative, so I can take the reciprocal. And then to get from 49 to 7, what kind of power is that? It would be 1/2, so negative 1/2. And then last one for this section, 16 to what power gives us 2? So what kind of root of 16 would give us 2? Not a square root, it's a 4th root. So this would be 1/4. Questions for me so far today? Okay. For the bottom of page 12, we are going to talk about how to evaluate logs with your calculators. If you have a TI Inspire, I want you to pull it out now. Okay. If you have a scientific calculator, I'm going to talk about those in just a second. But if you have a TI Inspire, I want you to pull out your TI Inspire right now. You need to be on some sort of calculator page. So if that's Scratchpad or if that's a calculator document, either is fine. And then I want to show you where these buttons live. Okay. So on my TI Inspire, just to the left of 1, you have this sort of double button key, e to the x and 10 to the x on the same button, right? They're just half of the same sort of button. And then right above that, you can see ln and log. ln is what we call the natural log, and it is a log whose base is e, log base e. Let's just move this over for just a second. So when you take the natural log of something, that is a log base e. We just have a special way to be able to write that, natural log, okay? For anything else, you would use a log, okay? So what we've seen so far has been primarily just log base something. So if I hit the blue control button and then this key if I want natural log, or this key if I want log. What I want you to see here is that what pops up on my screen is a space to be able to type in the base, and then a space to be able to type in the argument. So for example, if I wanted to do this third problem, log base 3 of 128, to type that in my TI Inspire, you would type the base and then arrow over to be able to type the argument. And then you hit enter and you've got your log there, okay? If you do not see the base, that means your base is 10. If you do not see a base, that's called a common log, and the base there is 10. So on your TI Inspire, in that spot to type the base, you would type 10. Okay. When you wanted to do a natural log, you would hit the blue control button and then that E to the X key to get your natural log. So if you're using a TI Inspire, that's what your calculator entry is going to look like. If you are using a scientific calculator, okay, I know we've got lots of different versions of those. If you're using one from my counter over there, they're going to look a little bit different than the two that I'm showing you. I'm going to give you a couple of examples. Your calculator may have the buttons arranged differently than the couple I'm going to show you. That's okay. If you are struggling to find where your buttons live, then you'll have a minute to ask questions here in just a second. So one version of a scientific calculator that I have here, we've got a log button. We have a natural log button. If I hit the log button, notice that it does not give me a place to type in the base. That is very common for scientific calculators, okay? For every scientific calculator I have seen today, nobody's had the option to be able to enter a base. That means a scientific calculator is always operating with log base 10. So for this first example, that's fine. Log of 7, I would hit enter and get my value, okay? And that's fine. For a natural log, this calculator has a separate key for natural log. Again, that's fine. I have another version of a scientific calculator here where my natural log and log live on the same button. If I hit the button once, it's natural log. If I hit the same button again, it gives me log. Again, notice I don't have the option to type in a base here, so it's base 10 by default. If you are working in a scientific calculator and you need to do a different base, like our other example here, then you have one extra step. It's not a hard, complicated step, but you do have one more step. You have to change the base to be able to work in base 10, okay? That sounds scarier than it is. What you are gonna do is enter this in your calculator as a log of 128. So this would be log base 10 of 128 divided by log of 3. So if you are entering something in a scientific calculator that has a base that's not 10, you are going to do log of the original argument divided by log of the original base. Okay, this is called change of base formula. What we're doing is changing this log to be base 10. Okay? And then you will just hit enter. When you type this in your calculator, though, you do need to be careful. So if I type this in, log of 128, I need to close that parenthesis and then divide by my other log. If you don't close that parenthesis, then you are doing division within the argument of your first log. So just be careful how you enter these, okay? And then once you close that parenthesis and type in the rest of your division, you should be fine. So I would like you to try the problems at the bottom of page 12 in your calculator, whatever kind that you have. If you can't find your log button, please let me know and I will come help you. But I want you to try these on your calculator now, and then we'll check them together in just a minute, make sure everybody got the values that they should have. Just again, make sure for whatever calculator you are using, you know where to find those logs or log and natural log. If you're borrowing one from my cabinet over there, again, make sure you know how to type in a log. Okay, so for this first one, log of 7, we should have gotten 0.845. And then the natural log of 0.25. Again, this is log base E of 0.25. Okay. But you should have a way to type natural log on whatever calculator you're using. You would get here negative 1.386. And again, I'm rounding to 3 decimal places. Your decimal values are going to go beyond this. And for our last one here, 4.417. Questions on any of those? Mm-hmm. The ln? Remind me in just a couple minutes and I'll look at your calculator. If you like legitimately don't or can't find it, what you can do instead is log base E. So if you're doing this on a scientific calculator, then it would be the log of 0.25 over the log of E, which is a little bit of a hassle. I'll look and see if you've got it, but we'll double check. But this is going to be our like workaround for right now, just in case. The last thing I'm going to do today is a little more evaluating, but in the form of a table. Okay? So on the next page, we're going to create a table for log base 2 of x and log base 3 of x. Remember that we are looking at 2 to the what power would give us x. But this time, this is actually our y value. The exponent is our y value. There are a couple of ways that we can think about creating a table for something like this or a log. For some people, it is easier to think about plugging in y values and finding the x. So for some people, the easier way to approach this is to say, well, I can do a -1 exponent, or I could do a third exponent, a cubed exponent, right? 3 for my exponent. Okay, I can do any of those, that's fine. So if I wanted to pick values for the exponent to plug in, just remember that you are actually choosing y values, but this is really similar to the table we saw at the beginning of our notes last time, where we had y values selected and we used the y values to be able to find the x. So if that's what makes sense to you, that's okay. So this would be 2 to the -1st equals what? Well, that would be 1/2. So our x value is 1/2. This would be 2 to the 3rd power, and 2 to the 3rd power is 2 to the 3rd power is 8. So your x value had to be 8. But I do want to talk about how to approach these the way we would for any other function, which is we pick values for x, and we plug them in and see what we get for y. So if we choose the input, we see what we get for the output. So if that's what I'm doing here, right, I want to pick things for x that would be easy to figure out the exponent. 1 would probably be a good value to choose. Why would 1 be a good value to choose? 2 to the what would give me 1? 2 to the anything to this exponent would give me 1. 0, yeah. 2 would also be a good value to pick. Why would 2 be a good value to pick? Because the exponent would just be 1, right? I wouldn't pick 3 here because 2 to some power that gives me 3, I don't know, it's not a nice number. I would pick 4 because 2 to what power gives me 4? 2 to the 2nd power. I could also pick 16 Because 2 to what power would give me 16? 2 to the fourth. So what am I doing when I'm picking x values here? How am I deciding that these are good values? What do they have in common? 2, 4, 8, 16. They're all powers of 2, right? They're all nice powers of 2. So 1 is a good option. And then any powers of 2. I could pick 1/4. Right? That would be 2 to the negative second. I could pick 1/8. That'd be 2 to the negative third. Powers of 2 would be good options for x because they would make my exponents be reasonable numbers. How about log base 3 of x? This would be 3 to some power equals x. What are some reasonable things I could pick for x? What might be a nice value? I would not want 0. We'll talk about that in just a second. Remember, x is not the exponent. If I use 0 as the exponent, what would I get for x? 1. 1 would be a good value. 1 would be good. What else would be good? 3 would be good. 9 would be a good one. Why not 6? 6 is what? Is 6 3 to some power? No, so be careful there. 6 is not 3 to some power. 9 is 3 to a power. What's another one? 27 would be a good one. Could I do 1/3? Sure. So 3 to what power would give us 1/3? I took a reciprocal here. -1. 3 to what power would give me 1? 3 to the 0 power would give me 1. 3 to what power would give me 3? 3 to the first power. 3 to what power would give me 9? The second power. 3 to what power would give me 27? Third. 3 to the third power. Now, 0 is okay for an exponent, but it's not okay for a value for x. Okay. And I want to talk about that for just a second. I cannot have 3 to some power equal 0. I can also not use, I should say, a negative value. So for example, I would not want to do -3 as a value for x. Why can I not do 3 to something equals 0? These would be bad. Remember when we use an exponent, I'm saying 3 multiplied by itself some number of times. How many times do I have to multiply 3 by itself to get 0? I can't do that, right? And then remember, it's +3. How many times do I have to multiply 3 by itself to get -3? I can't do that either, right? If I plug in 0 for the exponent, I would get 1. If I plug in a negative value for the exponent, right, I can do that. I can plug in -1 for the exponent, but that would give me 1/3, right? So I won't ever get a negative value out here either. Those are the only couple of things that you need to watch for when we're working with logs when I'm evaluating them. I never want the argument to be equal to 0. I never want the argument to be a negative number. Questions for me for today? All right. You have a Delta Math assignment over evaluating for homework for tonight. Be careful with your problems. I suggest that you write out the